What we're looking at here is a real request made by Chrome for a CSS file from one of my favorite places in the world, Sagrada Familia, for the Sagrada Familia website. I want to go through the request and response almost line by line, because once you understand what these headers mean, the network tab inside Chrome DevTools becomes much less mysterious. Let's start with the request headers. These are instructions and information that the browser sends to the server. At the top we have authority sagradafamilia.org. Authority is basically the host name the browser wants to contact. In older HTTP versions, you would mostly think of as this the host header. Here we are using HTTP2 style pseudo headers, which is why it starts with a colon. Then we have the method get. This tells the servers what we want to do. Get means that we are asking the server to give us a resource. We are reading. We are not creating or modifying anything. The next one is path. This contains the path of the resource we want. In this case, it's a AUI CSS file, as you can see here, this part over here, together with the several query parameters such as browser ID, theme ID, language, and version information. Then we have the scheme, which is HTTPS. That tells us that this request is made over HTTPS, so the HTTP traffic is protected by TLS while traveling across the network. Next we have accept. Text CSS */* q equal to 0.1. So what's this? This is the browser telling the server what type of content it expects. Chrome would prefer CSS because this request was made for a style sheet, although it says it could technically accept other types as a lower preference. Then we get to one of the most interesting headers for this example. It's Accept-Encoding, gzip, deflate, br from broadly, or cstd. This means that Chrome is telling the server, I support these compression formats. Gzip is a classic one, while BR means broadly and CSTD means Z standard. This does not mean that compression is happening. It only means that the browser is capable of receiving compressed responses. We'll check the response in a moment to see what the server actually decided to do, which is here on the yellow part. The next one is accept language. This tells the server that my browser prefers Spanish from Spain, with general Spanish as a second preference. Websites can use this when deciding which language to return. Then we have cache control. This one is slightly confusing because no cache doesn't necessarily mean never cache this. It means the browser is asking cache to validate the resources before reusing a cached copy. We also have pragma, no cache. That's basically an older HTTP mechanism with a similar purpose. You will still see this for compatibility. And then we have priority equal to, so it's U equal to 0. What it does, it gives server information about how urgently the browser considers this resource. A style sheet is important for rendering the page, so the browser can communicate its priority. Then we have referrer. This tells the server which page caused this request. In this case, the Sagrada Familia page itself requested the CSS resource. After that, we got several sec headers, as you can see here. Sec chua contains browser information. We can see Chrome and Chromium. As you can see here, the version of Chrome and the version of Chromium. Then we have chua mobile. This one. This tells the server this is a mobile browser. And this one, sec chua platform equal to Android. This tells that the platform is Android. These are called client hints. They give the server structured information about the client without relying entirely on an all-user agent string. Then we have three segFetch headers. The segFetch style tells the server, so it's this one, tells the server that the destination of this request is a style sheet. Then we have segFetch mode, and then no course describes the browser's request mode. And segFetch site same origin tells us that the page is making the request and the requested resource belong to the same origin. And finally, we have the classic user agent. This gives information about the browser operating and the device environment. Here we can see Android, Chrome 151, and other compatibility information. I've deliberately left the cookie header out of this example because cookie values aren't something I want to display publicly, and you should not share either. So let's move into the response headers. First, we have accept ranges, bytes. This tells the browser that the server supports requesting only part of the resource rather than necessarily downloading the entire thing again. Then we have access control, allow origin. The asterisk means that the service is allowing this resource to be accessed from any origin under the relevant course rules. Then we have the age, 80,182. This is interesting because the resource is being served through a caching infrastructure. Age tells us approximately how long in seconds this response has been sitting on a shared cache. Then we have cache control, public max age 86,400. Public means that the shared caches are allowed to store this resource. And the max age means that it can be considered fresh for 86,400 seconds, which is basically 1 day. And then we have the content length. This is telling the size of response in bytes. It's roughly 375 kilobytes. Then we have a content type, which is text to CSS. This tells Chrome what the resource actually is. The server is saying the bytes I'm sending you should be interpreted as CSS. And then we have the date. This basically is the timestamp at which the HTTP was generated or served. And then we have strict transport security. This is security header commonly in HSTS. It tells the browser that this website should only be accessed over HTTPS over the next 31 million seconds, which is roughly the coming year, basically. This is coming year. And then there is the XStorm cache. This says force static. This is standard HTTP header. It's specific to the site infrastructure and appears to describe something about how this resource is being handled by their caching system. And then we have X content type options, no sniff. This is a security header. It tells the browser to not try to guess or sniff a different content type. The server said this is CSS, so the browser should treat it according to the declared content type rather than trying to reinterpret it. And then we have X frame options, same origin. This controls whether the page can be embedded in a frame. Same origin means that it can only be framed or embedded in pages from the same origin, which helps defend against certain clickjacking attacks. Then we have X varnish cache, which equal to hit. This tells us that varnish, a caching layer in front of the application, already had this resource cached. A cache hit means that the origin application didn't have to generate the resource again. And X access protection, this is an older browser security header that enables legacy cross-site scripting, filtering some browsers. Modern browsers largely don't rely on this mechanism anymore, but you'll still find it on older or long-lived web platforms.